Thank you for joining Dr. Wong, Dr. Sayauer. We appreciate it. Obviously, we want to talk a little bit about your grant. Um, you put in an application for the home run grant application process, but this is connected a bit to some of the other projects, I believe, that were funded and approved by a previous grant. This was back in 2024. Am I correct?
That's
Yep.
correct.
But before we go ahead and get started, we wanted to let you know that your grant for $200,000 for multilamellar RNA aggregates and DMG has been agreed to for funding for
Oh, amazing.
$200,000. So
Oh, you're amazing.
Thank you guys. Thanks
it's
everybody so much.
Well, one, listen, thank you, um, really for investing in us. Um, Thank you for keeping this partnership going between myself and Gene.
I have, as many of you know, run a lot of clinical trials for a lot of pediatric brain tumors, including DMG, that really have no adequate treatment at all. Although one is excited for every trial that comes along, I have to say that this particular one really, I think, is one that I look at the mouse studies, I look at the preliminary data that we have already, and there's nothing else that I want to see move forward faster than what we have here. And to have you guys sort of help us salvage a trial that I am so optimistic about within the context of what a trial can represent. But it's an incredible statement, and we're so appreciative of the partnership.
It's
Thank
kind
you.
of cool when these grants go generational like that. And certainly want to talk to you a little bit
Well,
about the success of that. But before we do that, I want to introduce Tamara for some other words.
thank you.
Good evening. I'm Tamara Ikis. I am the president of the Reflections of Grace Foundation and also the vice president of the DIPG DMG Collaborative. And we are thrilled to be able to present this grant to you guys. We have been working for a while and really appreciate the generational aspect of this grant and the fact that we're onto something and hopefully we can see some success with this added funding. So congratulations, and we're so pleased that you guys are able to join us tonight. Just talk for a little bit with us. I'm going to
Thank you.
pass it off to Jill.
Good evening and congratulations. I am Jill Walworth. I'm the director of the Courage for Conley chapter of the Cure Starts Now. I'm here tonight to honor my daughter Conley on what should have been her 19th birthday, but is instead her 5th birthday in heaven. We are honoring her by supporting the research for a cure from the disease that took her from us. So I'm so excited to be here with you guys for this. I'm going to pass it off to Jackie.
Hi, thank you guys for being here tonight. I am Jackie Criswell. I'm with the Cure Starts Now. I'm their Director of Chapter and Family Support, but more importantly, I hold the title of being the proud aunt to Elena, who is a DIPG angel as well. Um, so thank you for the work that you do for the families like us. Congratulations. It means so much to see this work continue on because it's working. So thank you. Thank you very much. I'd like to introduce Rachel to say a few words.
Hello, good evening. I'm Rachel, and I'm the Research Support Coordinator at the Cure Starts Now. And congratulations on your award. We're so excited to see the results that come from your research. We acknowledge that you are an expert in this area, and we just appreciate all the efforts that you've done and all the work that you have done for patients, families, and in the field of research. So thank you so much. And passing it over to Keith.
Well, this is pretty exciting. I gotta say, I think this was the smallest application for a grant I've ever seen, at 4 pages. So the brevity was fantastic. But in your grant, one of the things that obviously stood out was how you talked about that the previous grant and project cured a large percentage of mice harboring DMGs. So can you tell us a little bit about some of these promising aspects of it and what's so neat about this next phase of your project?
But I don't, but Elias, you want to talk about you always
Yeah,
call it
yeah,
an onion, I think.
yeah. Well, listen, I think Gene doesn't get enough credit for how much he's done for our group. We've run into a lot of issues at the University of Florida moving this forward. Conflicts of interest. My role as a clinical investigator is essentially I can't be involved, and Gene is so that's the discoveries could have just sat there on a shelf, and Gene has, I think, been foremost in terms of my collaborations as someone who's really taken the ball, run with it, has not just ensured that the work is supported, but has carved out relationships with individuals, consortia, and advocates. And every one of those things, I would say, has been essential in securing funds, creating advocacy, enthusiasm, and collaborations with consortia that have been very excited about this. So, yes, our group has made many of these discoveries, but how many times has cancer been cured and sat there without it actually moving forward? And this is, I think, one of the challenges with a lot of discoveries is it's really up to industry to decide what moves forward. So I can't say enough about Gene and really helping to move these discoveries forward into patients, and has basically given us so many tools to do just that. To answer your question about the onion design, this is, fundamentally mRNA is information. It's the software of the human body. The human body runs on 4 letters, A, C, G, and U. So if a computer was a bunch of ones and zeros, our bodies run on these 4 letters. So there's really nothing to be scared of with mRNA. It's our software. But as information, it's programmable. Our software is programmable. However, as information, mRNA information has to be conveyed, right? It has to be delivered. A mail has to be delivered by a mail courier. mRNA is the same. It's information that has to be delivered. The delivery system for mRNA has been through these lipid nanoparticles. That's what's used in the COVID-19 mRNA vaccine. I'm oversimplifying, but that's a sphere. So it's a fat sphere where the RNA is inside. However, mRNA is negatively charged. So imagine trying to put a bunch of negatively charged materials into a sphere. It's only going to be so much you can package, right? The negatively charged material will repel itself. So this is a challenge in terms of how much payload you could deliver per particle, or how much information you can deliver per particle. To get around this, we created a little bit of a different system. This is very different from the LNPs that people might be familiar with at the COVID-19 vaccine. In this system, the RNA is essentially the negatively charged RNA surrounds a positively charged particle. So that's a positive and a negative, followed by another positively charged particle, followed by another ring of negatively charged RNA, and so on and so forth. So you think this would be a huge, giant particle, but it's not, because now it condenses into this supracoiled, multilamellar or onion-like particle, because when you have alternating positive and negative, it starts to collapse into a very tightly coiled particle system. And the value of that, to answer your question, is now you could deliver more information. If you could deliver more information, you could harness the immune system in a more potent manner.
It's good to support it. We're glad to be part of it, and we're excited to see what it bears for the future.
Thank you. Thank you.
Thank you all.
Our gratitude is really immense, and I think it has a very different meaning when it's families who have suffered the unimaginable. It carries a different weight. it's very sacred, these funds. And, Gene and I certainly don't take that lightly. We do this because we want to make an impact for a disease that, has essentially remained incurable. It's our hope that through this work, we're going to get closer to that cure. I believe that. In my heart, I honestly believe that. I can't promise that this trial is going to be the trial, but in my heart, I do believe that what we learn from this trial will put us on the path towards curing this tumor. I believe that vehemently.